In the previous video, we created a neuron that helped us put on a coat depending on the weather conditions. We adjusted the neuron to suit the needs of different people using the weights of the neuron's inputs. But we selected the weights manually, and the tuned neuron only worked for one specific person. But how do we make our neuron able to predict decisions for any person? You would say, add another input, the type of person, and you would be right. But how to determine the type of a person using numbers from 0 to 1? Why exactly this range? I will explain later. But let's go back to the types of people. I suggest we break down the type into subcategories: gender, age, health, temperament. Add the size of the coat, the type of activity that the character plans to do outdoors. We connect all this to the neuron. Wow! You probably don't want to manually select weights for each parameter. But it's not necessary to do it manually. Let's try to train our neuron using a computer. We will conduct training in several stages. Preparing data for training. We create a survey that describes all the parameters we decided to account for in describing the type of person, as well as add various weather conditions and decision options on whether to take or not to take a coat for each weather, and we ask different people to fill out the survey. Each respondent describes themselves and then indicates whether they wear a coat in different weather conditions. Having received a certain number of filled surveys, we are ready to train our system. We'll set aside a few surveys. We'll use them later to test the train system. We create a program that feeds into our neuron the survey data of each person and the weather conditions in turn. Also, by adjusting the values of the input weights, it tries to get the survey decision at the output, whether to take a coat or not. We do this several times with the whole set of surveys. Now we take the test set of surveys, feed them into the neuron, get a response, compare it with the answer in the survey. And the neuron gives absolutely incorrect results. All our training failed. And all this happened because it is impossible to describe the behavior of different people by simply summing the inputs, even with selected weights. One neuron is not enough for this. What to do then? Let's take not one neuron, but say 10, and connect them in parallel. We sum their outputs in another neuron, called the output neuron. We get such a picture. It's already a neural network. Although inside not one neuron, but 10, we still have 9 parameters at the input and 1 output. Let's try to run the entire survey set through this system several times again, adjusting the weights to the output values. We check the trained system on the test surveys, and a miracle. Our neural network correctly predicted some of the answers. The training results have improved, but why? If you try to analyze the weights of each neuron, you can find that the neural network has grouped the input parameters into groups that most influence each other. For example, health and type of activity. It is clear that a healthy person who is going for a sports run will not wear a coat. In this way, the output neuron sums up groups, not individual characteristics as before. That's why all this started to work better. Our neural network can create up to 10 such groups. Add more neurons, and more groups can be made. And the more groups, the more precisely you can describe behavior. Such a stack of neurons is called an inner layer. In real tasks, it is necessary to add more layers that go one after another. And what the neural network does with the data, we can't even imagine. Although we can see it, and it's incredibly interesting. I will show you examples in the next videos. Subscribe, like, dislike. Until new meetings.